So diving in, 4u4, just the really 10,000 foot simple approach to this is it's DiGiCo's way of actually making an affordable console, affordable small console. Obviously, there's a lot of companies out there that make affordable small consoles. DiGiCo is a bit unique in that we try to approach things with a premium touch, both in features, in obviously audio quality, longevity of the product and the support and the development for that, which kind of goes against a lot of companies and how they approach cheap, inexpensive consoles. So what we essentially did was took four small consoles and shoved them into one chassis. This concept is not new. It's more commonly referred to as centralized DSP, and obviously this has two components of two different markets to it. The one we're primarily covering today is the install market. So we are trying to primarily talk about houses of worship, theaters, corporate install, hospitality, sports applications, cruise ships, and then of course live venues as well. So we're going to talk about that briefly a little bit later. Basically any area that has a small channel count or multiple areas that have small channel counts that do need quality audio. So let's dive in a little bit. So first off, it's a giant matrix. There's no surprise here there. We're going to go over the specific IO counts and everything it can do and the different ways to get in and out of it. But the idea is it's a giant point-to-point matrix. And then like the centralized DSP, it is a remote mixing system. So we've essentially stuck all these consoles in one chassis, and then we're going to attach controllers to these. We're going to have hardware and software controllers. This is all based on a flexible, low latency FPGA processing. So if you've been around DiGiCo or you've been any experience with us before, you're going to know that we base a lot on FPGAs. So this allows us to do very simple point-to-point routing, any input to any output, anywhere, and just give us that flexibility to change the architecture as needed over time. In addition to that, we are running at 24-bit 96K. Now, one interesting thing about this product is it is 96K only. And so we're going to talk about how we handle getting in and out of the system as well. And the UK has done a good job of giving us the tools to be able to take care of that. So we'll go over that in a minute as well. There are over 500 inputs and outputs to the system across a multitude of protocols. You can connect a 4u4 with the DiGiCo family of products. So more commonly, it's going to be the SD range, so something like the SD9, SD12, all the way up to the SD7, including the new Quantum 3. But you're also going to be able to connect things like S-Series. So an S21, S31, we're going to be able to send audio to and from. We might not have the full control features you have on the SD, but you are going to be able to have audio passing back and forth. And then, as I mentioned before, we have hardware and software controllers. So some of the hardware controllers are just essentially PoE-powered remote fader packs. Encoders, we have in-wall units. So I actually have one of these guys here as well. So this is what's called an A-Control 1. This is meant to be a single gang decor style input that is PoE-powered, things like that. You also have Mac and PC software. You have iPad control, all with user-level permissions, which you're going to get into as well. In fact, that's the very next point. Admin level programming. Within that, you have area access, so we can actually control and limit somebody being in one area, or so like just the main worship center, or just the chapel, or just the room 1 in a meeting room or something like that. We have user level access, so that would be like giving Kyle access to the system, but he'll have access maybe to all areas, but he doesn't have access to everything as far as how it's configured. Maybe he just has mixing functions available across those areas. And then we have the iPad user access. So this is a different level of access that you would probably say, okay, let's give them a specific area. Let's give them just the ability to mix and change EQs, dynamics, etc. Now, one of the things we introduced with the 4u4 system was plug-and-play proprietary audio distribution protocols. These are two different protocols. One is called A3232, and unsurprisingly, that is 32 channels by 32 channels at 96K. This runs over a Cat5e or Cat6 cable, is point-to-point. It is layer 2. It can pass through certain switches and media converters, but primarily you're going to take it from an A3232 port on the 4u4, and you're going to take it to the device in hand. So something like one of our stage boxes or our in-wall I/O. Now, if you multiplex all of these together, so actually 4 A3232 streams, you get what's called an A star stream. So this is a gigabit layer 2 protocol, and it's essentially just muxing those signals together. There's a breakout box for this as well, and we're going to show you all that. There is optional I/O and integration via Dante. So at ISE, I think it was about a month and a half ago, they announced the Dante versions of the same I/O that we have. So you actually could mix and match these together or run an entire setup on the A3232 protocol, or you could do another setup entirely on Dante. So if you're comfortable working in Dante, the rest of the infrastructure is already in Dante, or they just need the flexibility of being able to move an I/O box anywhere around the room or the facility, then that's probably the direction to go. That's going to happen via DMI card, which we'll also talk about in a minute. A hidden feature that we don't really advertise, but I feel is really nice to have, is called auto-updating firmware. This means that as we update the firmware on the box, and we actually choose when we do that, but as we plug in other devices, so any of these controllers, any of the I/O boxes, when we do that, it's actually going to automatically update their firmware to the latest version. So as soon as it's powered on and connected via the network protocol, you'll be able to see that. And then, as mentioned before, we have Mac, PC, and iPad software, various levels of user access control that we can set up, but there's a lot of different ways to be able to get in and control this platform. All right, so the 484 itself, as I mentioned, it is a giant matrix. So we have 256 inputs and 256 outputs that are available via that proprietary protocol, both the A star and the A3232. In addition to that, you have 256 inputs and 256 outputs via 4 DMI card slots. So each of those being 64 channels by 64 channels. Then you have 24 inputs locally and 24 outputs locally. So if we do some math, that brings us up to 536 inputs, and technically it would be 538 outputs because we do have a headphone jack on there as well. So, and then if we're looking at this a little deeper, so back to this whole matrix concept, it can be a point-to-point router. We can take any input to any output. We can use what's called a tie line feature for this, as well as just your standard input-to-output patching. So we can involve DSP, or we can go point-to-point. You can also use this as background format conversion. So in some of the larger installs that we've done with this already, you're basically taking protocols like Dante and converting those to octa-core while you're just like separately running DSP for your other rooms and your other venues. So these are things that don't have to happen together. They can run separately and give you access and control to whatever format you really want to interface with. There's also sharing of SD consoles, racks between 404 and the SD range. So we can take things like the 168 stage box, which is a 16 by 8 portable stage box, which also has a rack mount option. And then we can tie that and connect that to an SD12. So this will work like essentially a hub to connect all the A star and A3232 IO to an SD series range. Now, Kyle, I do think you were actually talking about a church that you recently did a training with, and that church actually used this to interface a lot of different components. Could you tell them just a little bit about that and what it was interfacing?
Yeah, so the whole idea was they needed, they had a couple overflow rooms that they needed as flexible spaces. So they had just Cat5 wiring that was wired into each of these spaces, and so they could drop stage boxes as they needed. But the whole idea was in this church campus, they needed to have access to anything from the main sanctuary to the video room to the overflow rooms. They needed access with all of that. So what they did is they had a Control 8 in each of these overflow rooms, along with a like a Dell Optiplex touchscreen computer. And then with this, they also were able to take Dante for playback for their Ableton rig that was in the video control room, and that would broadcast onto 484 and then split it to all 3 venues at the same time. There was 3 SD12s on the network. There was that was combining everything into 484 through octa-core. And then they had some MADI streams going into video. So they were hitting a ROS embedder. So they're taking MADI into ROS and then back from them. So the whole campus, yeah, the whole campus was tied together with 4 Area 4 with 3 DMI slots being Opticore, Dante, and MADI slots. So just a lot of flexibility, being able to put everything onto the network and then to be able to pick and choose what you needed to take off the network.
Fantastic. Thanks, Kyle. We'll come back in a second to talk more about that integration and how it was tied together with the SD consoles being able to control I/O that it lives in and connected to the 404. So after the point-to-point router, on that flexibility, we actually need to go and look at the core of the processing. So we actually have FPGA-based audio processing, so similar to like what we have on S-Series and SD-Series consoles. You have 128 channels of full DSP. So this means high-pass filters, low-pass filters, 4 bands of parametric, gate, de-esser, multiband comps, things like that are available for you to be able to put on the input channels. You also have 48 full DSP outputs. So things like auxes, groups, or matrix, these are configurable, much like you're used to on a DiGiCo as well. So we can adjust the number of auxes and groups, matrix sends, but they do pool together to form 128 ins and 48 outs, and then you distribute those across the areas. In addition, you'll have 4 stereo DSPs for the areas. So basically think stereo masters. So each area is going to have its own master output. You're also going to have 4 stereo solo buses that are unique to each area. In addition to that, you're going to have source selectors. So these can be physical. On the front of the unit, the 404 unit, we'll show you a photo of that in a minute. You actually have 8 macro buttons. You also have things like an A control 1, A control 6. If you can see my screen, you're going to see that I have an A control 8 right here. This is essentially a PoE powered 8 faders by a couple of different banks. And all of these guys can be set up to not only control sources, but also give you level control at the same time. And then we have, lastly, Kyle alluded to and talked about a little bit, we're going to do DiGiCo SD integration. So this is allowing us to be able to take an SD12 and be able to control the preamp of one of the stage boxes connected to a 404 system, and also be able to pass labeling and things like that in the future. So now let's talk about applications for 404. First off, cruise ships, theaters, performing arts centers, churches, hotels, any type of hospitality, theme parks, broadcast events. We have quite a few of these systems out as portable mix packs, essentially for broadcasters that don't need a full-blown audio console. So they can stick this audio core in, set up everything they need, and then be able to have that fader pack for their operators to control, and they don't have to take a full system for this. And then we have live festival matrix with processing. So this is a unique application as well. Well, previously there would have been a lot of festivals going on right now. And you can use this as the core of switching between multiple consoles. Some may just be feeding you stereo, some may be feeding you left, right, front, fill, sub. You may have different protocols. Some may be sending you via Dante, some may be sending you via AES or analog, and you can switch between all these, including doing limiting and processing on those inputs before it goes out to your routing distribution platform for like amplifiers and just across the venue as well. And then, as mentioned before, the point-to-point I/O matrix solutions. And then really any space that has multiple areas that you need the features of a full-blown system, but you don't have the budget for it. And so we'll talk a little bit about pricing later on and kind of where this fits, but it is a very affordable system, especially if you divide it before. All right, so to help you understand how we split up the I/O, this is basically showing you your different areas, so 1, 2, 3, and 4, and then we each have a master and a solo bus per area. So that comes standard. Now we have 128 channels of DSP, and then we have 48 auxes, groups, or matrix with full DSP, and we get to assign those per area. So in this first example, you can see that we actually put 100 inputs into the area 1 and 30 buses. The area 2 has 20 inputs, 10 buses. The third area, 4 inputs, 4 buses. And the last area, 4 inputs and 4 buses. And this can be configurable, so we can actually change this as needed. Maybe you have some sort of application where you're not using the other rooms and you're doing a big event in the first one. Now we can do 128 by 48 buses all in that first area and not leaving any DSP for the remaining areas. Or probably more commonly, you're going to see 32 inputs across each area and then 12 buses across each area. So just once again, trying to show you guys how we can distribute this IO and this DSP across the 4 areas. Now, talking about the unit physically. So this is the front of the unit, the rack mount unit. And you're going to see first off that it is a 19-inch rack mount. It's 6U high. You're going to have things like a headphone jack and level control right in the front. This makes a lot of sense if you have your laptop, you're actually in the control room or where the equipment is, and you just want to be able to monitor sources. You want to know that things are coming in properly into the system before they're going back out again. Great way to be able to do it. You also have 8 macros. So these buttons can change color if you need to. These are TFT displays, so we can actually put a bunch of different text on them. You can configure these for recalling specific snapshots, which can change layouts within the areas, routing, channel names, aux levels, all those types of things can be recalled here as well. So it could be very simply, I want to configure this for 2 rooms, 4 rooms, or break this out into different areas, and you can do this by the push of a button on the front of this. There's also another TFT display that'll show you status indication, so if the power supplies are up, what the firmware version is, etc. There's a network connection on the front as well. Once again, this is meant for being in the equipment room and just needing to quick plug in your laptop or whatever you have to control this box.
Also, hey, Ryan, can you go back one slide?
Sure.
Sorry. The one thing that we didn't talk about there is there is behind that cover plate, there is a USB.
You're right.
Yeah. So with that, you're able to, if you've got media, if you need a playback announcement for a fire alarm, something like that, you can load up a USB with audio media for it to be able to play back in any of the 4 areas.
Yeah, you can store those as WAV files and stash that on a USB drive and keep that out of sight. So, very cool. Thanks, Kyle. All right, moving on to the rear of the unit. This is obviously coming fully loaded here. Typically, this would come without any DMI cards or any SD racks, and then you just order it a la carte for what you need. So there are, starting with 2 redundant power supplies. So you only need one of these to operate. If this is a mission critical system, makes sense, you can tie one of these power supplies to a UPS system. You have 4 DMI card slots. So if you're not familiar with the DMI platform, this is a DiGiCo multi-channel interface. These are the same cards that are available for orange boxes, for SD12s, Quantum 3s, Quantum 7s, and 5s, as well as the S-Series consoles. So any of those cards and then some. So there are some that are unique to working with the 4U4 system, and things like the DMI Opto, which you see in here with the HMA connectors on it. That is unique to the 4U4 platform as well as the orange box. Yeah, any of those others across the system will work in here. Then you have 3 SD rack card slots. So these are meant to literally take out of an SD rack and you can put them in here. Basically premium IO that's built right into this chassis. These can be configured as all inputs, all outputs, or IOs. And we'll go over that in a little bit more detail in a minute. And then you have a network connection in the top left corner of this. That is just a switched connection to what you see on the front of this. Think attaching all my controllers. That's where these are going to attach. This is my network with my access point where I can connect my laptop into, maybe my PC in my office that I'm going to be controlling or administering this from most commonly. iPads are going to connect to this access point as well to be able to control their specific areas. In addition to that, you have the A-star ports. You have A-star 1 and 2. 2 works as a redundant to 1. So if you're using the redundant protocol is when you would use 2. So primarily you're just going to be using A-star 1. And once again, that is 128 channels by 128 channels. That heads out to a breakout box, which we'll show you in a second. Then you have 4 individual A3232 ports. These are 32 channels by 32 channels. You connect onto the first I/O directly from here, and then you cascade onto the second. And this should give you 128 by 128 as well across those 4 connectors. You also have word clock in and out. So if you are trying to sync to a video system, much like Kyle mentioned before with that ROS embedding, then you're probably going to want to take or send word clock, depending upon how the setup is configured. And then lastly on here, you have GPIO. So Phoenix connectors providing us general purpose inputs and general purpose outputs. So here we can actually go in and have remote devices, contact closures, things like that trigger certain scenes or elements. So in addition to what we have on the unit, we actually have a network-based version of the GPIO. So you can remote this out, maybe closer to a projector lift, or to turn on and off the display, things like that. So let's talk about some of the different peripherals and how we control the system. So here we have what's called the A-Control-1. So this is a single rotary switch controller. So that rotary is actually a push button rotary. So once again, you probably cannot tell from there, but this guy will actually let me control push in and out. It doesn't want to focus on it, so there you go. So we can control in and out in here. So we can you know, shift, if you want to think about it that way, shift between different sources and select those. And when it's in its primary mode, so not pushed in, we can control the volume source of this. Now, there is a way in the settings as well, so we can limit the volume range. Those of you who do installations probably know that very seldom do you actually want something to be able to turn all the way off in a permanent install. Most of the time you're going to limit those to a certain, like a -40 range or something like that. So it's quiet in the room, but it is never off. And then you can have control over specific functions in addition to that. There are, this is, as I mentioned before, a single gang DiGiCo style plate. They have a European, Euro style as well, though primarily, obviously, what we're bringing in are the USA or DiGiCo single gang styles. And this is PoE powered. So just run that network connection, come off of an appropriate PoE switch, and you are good. This is called A-Control-6. Basically, we're taking 6 of the A-Control-1s, putting them in a box, adding mute and solo buttons, as well as the ability to have bank selections here. So in addition to just being 6 encoders, we actually have 6 buttons at the bottom there below the encoders that allow us to select between banks or fire specific things like snapshots or scenes from there. And also PoE powered. The larger version is the A-Control-8. This is 8 moving faders. This actually does require PoE+. So there's a little more voltage needed for moving all the faders, but the faders are actually quite nice. Really do like having those. So you still have 6 bank buttons. They are to the right of the faders. So these can be banks, layouts, or as before mentioned, snapshots, triggering GPIs, things like that. Mute and solo, as well as TFT displays. Here is the A88. It's a GPIO module that is network-based, so we can remote these out wherever we need to. So it's 8 GPIs and 8 GPOs on one box. And then the GPOs are triggered by the console or the 4u4 in this case, and GPIs are triggered by contact closure. So you can either have our system, so the 4u4 system, respond to something externally, a push button on a system, like you want a simple, like let's say you have Crestron control and you want it to go into an auto mic mixing mode for a panel discussion or for somebody to just give a presentation. Set up, hit the button on your Crestron controller, it's going to send a GPI into this, and then it's going to configure the system appropriately, assigning the input levels turned up, automatic mic mixer being turned on and assigned to those inputs as well. This is also PoE powered. And then you have the software. This is going to be your main interface. We're going to take you through this in a minute. And that is going to be where we can administer all areas, as well as the users. This is Mac or PC software, and then we also have tablet control. So you'll see here in a minute, there's an iPad. We have basic MIDI over TCP/IP, so this is MIDI over networking protocols. And then on the list, we have some Crestron and AMX integrations coming as well. Don't have a timeline on those. Tim, don't know if you have anything to add to that. If you do, you can chime in.
Not at the moment. Not at the moment.
On the roadmap, shall we say.
Absolutely.
All right. And then as far as I/O goes, we actually have, via those A3232 ports, this is a 164 wall LCD. And probably the best thing about this box is that it has integrated LED scribble strips. So as you name an input in the software, so let's say channel 1 is labeled kick, and then I assign it to socket number 1 on this I/O, it will actually light up blue for being an input, and it will say kick right above where that XLR sits. I have another photo in a second that'll show you the scribble strips on, and it is wonderful. They actually time out, so the backlighting on these. So if you install these in a venue where they're actually facing the audience or the audience can see them, the left stage left or stage right or upstage, then, sorry, downstage. You would have these. These will actually, the backlights will turn off. So there's, I think it's preset for like a minute automatic timeout, and then you can push the button to turn them back on when you're actually setting these up. If you want to think about the ultimate in volunteer friendliness for a church, it's this box, because as we configure the room, recall one of those macros or something from our iPad or a laptop, we configure the system, the actual inputs themselves will be labeled. So anybody coming in to plug in and they're just looking for where that vocal microphone is going to plug in, it'll be labeled on the particular socket that they need. So this runs, of course, off that A3232 protocol. It's going to have a redundant connection, or more commonly, we're going to use this in a daisy chain configuration. So you're going to see that it can take two boxes, can be daisy chained together, which means I come from my 404 to the unit, and then a daisy chain onto the next one. You're going to see here that we have hardwired or IEC connections from 100 to 240 volts. We also have, we can power this off of 12 volt supply if we need to as well. Here, the line drawing has been upgraded so you can see that we actually go to the first unit and then we daisy chain onto the second one. The order doesn't matter as far as physical wiring, but it will determine the routing as it's shown up in the 404 software. So this is the 168 stage. This is a portable stage box, 16 mic line in, 8 line outs. Of course, it works off the A3232 protocol as well. Once again, redundant or daisy chain configurations, phantom indication, the same kind of 100 to 240 volt universal power supply on there as well. And you'll see these on the right-hand side of the screen just connect right into those A3232 ports right on the back of this unit. So there's no need to go through any converters or multiplexers or breakout boxes. We can make a direct connection here. All right, so this first connection, so we're actually looking at a daisy chain configuration here. So channels 1 through 16 are on the first box, and then we go out of that cascade port into the second box, 17 to 32. Both of those make connections to A3232.1 on the main unit. The next connection here we're actually going to show is a redundant connection. So this would be something that's really important. So we obviously, or maybe a high traffic situation where the chances of somebody running over a cable, disconnecting something are high. So we can actually run redundant connections. Obviously that eats up 2 ports just for 16 channels. But once again, when something's that important, probably worth it. Now, here is that A-star multiplex box that we talked about earlier. So simply we're going to take in an A-star to A-star connection. So on the right side of the A-star box, you'll see it connects to the actual 404 A-star connection. And then we have 4 A3232 ports. So this is going to be just like you were connecting to the 404 unit, except now we're going to have connections into this breakout box. Now, you can use this and do a couple of things with it. One, just add more I/O to the system. There's no problem with that. Everything can live close together. Also, you have 100 meters between the 2 points. So we can actually go from the A-star port on the unit to the breakout box via Cat5. If we need longer than that, so building to building type connections or a large facility, we can actually convert this to multi-mode or single mode fiber using fairly standard layer 2 media converters to get a hold of these. This A-Star port is a gigabit connection, and then the A3232s are a 100 megabit connection. And then we're going to show you just some more simple connections as you go through here. But you're going to see channels 1 through 16 on the first, channels 1 through 17, just like that connection was made to the main unit. And then if you want to turn things into redundant, add 2 of the A-Stars and then take 1 connection from a portable box and 1 connection from a main box and come in here for that. All right, so let's talk about the DMI card slots, which are available and which will actually work with the 4u4 system. So first thing you have is a MADI B and C connection. This is actually quite popular. I think just about all the units we've sold have this, whether it's tying to a DiGiCo system or to a like a ROS video system, video router. Everts would be able to handle that as well. And then there's a MADI Cat5. So this is the same protocol, but with using the MADI twisted pair Cat5 connections. You can do Waves cards in here. So if you need to add Waves plugins and processing, you can do that. Obviously, there's a Dante card. There's the standard Dante, and there's the new Dante 2 card, which is 64 channels at 96K with automatic SRC. So if our Dante network is running at 48K, we can do the up and down sample rate conversion to be able to interface with this unit. Then there's an OptiCore card. So we can order this with the HMA connectors for touring applications or portable applications. We can do it with optical con or with ST connectors. So a house of worship, permanent install, larger facility that's going to tie in maybe a theater, performing arts center that's going to tie into a DiGiCo SD series console via OptiCore. That's probably going to be done via ST, just easier to work with and cheaper. There's an Aviom card available as well. There's analog I/O via D-sub connector, so you're going to see that in slot number 1 up there on the presentation. You're also going to see that there's a mic card, so 8 mic pre's directly on the unit if you want to as well, and then AES in and out via D-sub connection as well. And the little note down there that says the DMI port maxes out at 64 by 64 channels at 96K. All right, now here's another view of that A164 wall. This one is the A164D. This is what was announced at ISE, and I believe should be shipping in May or June. Along with that, there'll be a software update, obviously, for the 4u4 system, and that's going to allow us not only to be able to do audio over Dante, but also control. So we can have a Dante network set up with the Dante DMI card, control any of these boxes. You'll get the labeling, you'll get the colors, you'll get phantom control, mic pre-control, all of that over the Dante protocol. It's the standard kind of Dante implementation, so you're going to have either primary and redundant or a cascade or a daisy chain connection, depending upon how you want to use those. Same type of situation as well, where there is a 100 to 240 volt power supply, and then there's a direct 12 volt as well if you need a portable application for these. And then there's the A168 stage D, so 168D stage, so the Dante version of the stage rack. I don't think I mentioned before, but there is a rack mount chassis or ears for this as well. So if you need rack mounted I/O to go with the system, you'll get those stage box, and then you'll get the optional rack mount kit to go with it. So there's obviously a Dante version of this. And then, of course, don't forget all the other little Dante I/O boxes that are across our industry. So there's a lot of different versions of these from a lot of different manufacturers. If you're having small breakout rooms, meeting rooms, just, you know, we were working with one installation on just a lot of multiple teaching spaces. And an application like this where you can plug in just a couple of microphones, podium mics, lav mics, things like that would be probably a great application, and put it right onto Dante. It would be available to the entire Dante network as well as our 4u4 system. And then there, at the bottom of this chassis, there's actually 3 SD rack card slots. So the cards you can currently put in there are the 32-bit mic pre's, the 32-bit line outs, AES inputs, AES outputs, or the AES I/O card. So you pick and choose, configure this as needed for your install. A lot of installs may not even need this. We've seen this primarily being used in the festival situation. So when somebody needs to be able to have DJ input, somebody needs to be able to have a voice of God mic to emergency evac communications, things that are required nowadays at festivals. We can plug all those things in locally. We can take inputs from video locally or remotely at the stage or across other systems as well. All right, so let's go through a couple of example systems just so you guys can see how we are actually setting up the system and implementing it. So the first thing up here is actually a standalone install. So this is, we're using the 4u4 as it's intended just for a couple of different meeting spaces, a couple of, like they got, it looks like they have a live venue here, a rehearsal space that they may use as well, and then the couple of meeting rooms. And so we're going to start with the meeting rooms. You're going to see that there's actually A control ones that we can install, single gang boxes that can be installed within each of those rooms. And remember, those could be the overall volume for the room, or you could push and turn to select individual inputs so you can control microphone levels within that room or music being played back into that room. Somebody's got a laptop or something like that where they're going to want to hear audio into that room. All of those A control ones are actually connected to a PoE switch. This PoE switch is providing power to those units as well as control, and that is giving us a connection to our 4u4 system. Now, if we move on to the rehearsal space, I do believe I can actually, let's see here. Sorry about that. If I can get a little cursor here for you guys to see what I'm doing. So if we move on to this rehearsal space, we're going to see that we have an A control 6. This is connected up to that PoE plus switch as well to provide power as well as control. And then if we take the blue line here, we're connecting directly to one of those A3232 ports. So this is that A164 wall LCD giving us 16 inputs, 4 outputs in the rehearsal space. Now in the live venue, they've chosen the larger A control 8, and that's going to make sure that this is required to be a PoE plus switch, once again for control and power. We could have multiple destinations, so multiple mix points. I've actually talked to a couple people about building carts, kind of the mix carts, presentation carts, if you will, that have these built into them, and just a network connection to that is going to all it needs to power it up and to control it. And then here you're also going to have 2 A168 stages that are connected via A3232 back to this unit. And then you'll see here we can have the choice to feed out to our processing and amplifiers via Dante, or maybe just going analog out of here. We could have gone analog out of D-sub on this unit as well. It really depends on what you're going for in your install. And then this is a performance venue. So think performing arts center, a club, restaurant, something like that as well. Probably not a restaurant if you got a couple of SD7s, probably more like a theater application as well. But let's take a look at this on the green loop side first. So first you're gonna see this green loop is actually octa-core. So that is a fiber loop that is connecting our SD racks, monitor console, front of house console, and forming a loop. Remember, these connectors can be whatever you want them to be. So HMA for portable applications or ST for permanent install. We are still feeding out to our system processing and amplifiers via Dante or analog to the system. And then it's very similar over on this side. So we might have a dressing room, backstage, or foyer, have our A control ones built into the wall there, powered via PoE. We might have a bar area. We might have a jazz room, just different ways that you can set up and configure these systems. Here's a house of worship. So once again, just, small, medium-sized church with a couple of SD7s here. But we have our octa-core loop set up, feeding processing out directly from the amplifiers or to the amplifiers or our system processor with Dante or analog. And then here, probably because of distance, we're going to look at doing a run to the A star. So this gives us 100 meters via Cat5. We could also go through media converters, convert this to single or multi-mode fiber, and then we could break out into something like a chapel or a youth room or a cafe. Remember, these are places that it doesn't make sense, maybe even to put an S-series console from DiGiCo. Maybe they need something very basic basic in that chapel. We can build this into the wall, into the venue, into that chapel. Remember, those displays turn off. They only turn on when we need them and time out. We can bring a controller when needed, but maybe we're actually controlling this via an iPad primarily, getting that set up for a wedding or something in that venue. We might also have something like a cafe or a lobby area where they might do events from time to time, giving you options of those. In addition to those, we can put in our A control ones in various areas for just playback and level control.
Yeah, and on that, Ryan, when we're talking about A control ones, we have done some installs where they'll put one of these A control ones in, like, you know, if you're in a church and a coffee shop, for instance. So you've got the walk-in music that's always kind of playing in the foyer as people are walking in. You've got the ambient noise because there's a bunch of people in the lobby area. And then when the church service starts, then they're able to, you know, grab that A control one, turn down the lobby music, and then bring up the program feed, and then adjust the volume that they need in the lobby. So those are quite helpful, and we have installed quite a few of those before. So
nice.
Yeah.
Thanks, Kyle. All right, so here is a large theater application. So a lot of times theaters do not use monitor consoles, but here they have a lot of channels that they want to send via OptiCore. So you'll actually notice, excuse me, that we have 2 OptiCore DMI cards. So 64 channels on the first, 64 channels on the second. Those are going to show up as separate rack IDs. So we're actually going to have like ID 11 and ID 12 if you're familiar with the OptiCore system. Those are going to connect to SD racks, and we're going to form, once again, a loop with our system. Now, we could take that A star, that red line, go to the A star breakout, connect to all of our A164 walls, LCDs, the portable stage racks, etc. But the cool thing is we can tie this system together with the SD, so the SD console can be looking at either an input from the SD rack or an input from that portable stage rack, and be able to control the gain directly from the channel from either, no matter what the input is from, whether it's an like an A star input, an A3232 input, or from an SD rack. All right, Kyle, let's talk about, once again, back to that church you recently did that install at. And what we're going to do here for you guys is walk you through how you're going to set up and configure the control between an SD series console and the 4U4 system. Now, as you would imagine, there's actually documentation for this, but since nobody reads that, Kyle, will you take us through how it works?
Yeah, so, hey, Matt, is your microphone open right now?
Sorry, buddy.
Thanks. Okay, so again, as Ryan was saying, you're going to have your A-star boxes, anything that's Dante driven, anything that's AES driven, they're all going to plug into your 4 unit. From there, the biggest thing that they've added within the last 6 months is what they're calling tie line patching, that gives you the actual control of an A-star box from your SD console. So as you can see in the diagram there, we've got 3 A-star devices that are plugged in through our A32 ports. We're hooked up either via MADI or OptiCore into the SD console that can exist on the loop. So up to 5 consoles can exist on the network, plus your 14 rack devices in the SD world, including one of those devices can be for Area 4. If you want to go ahead and go to the next one, Ryan. So inside of Area 4, we're going to show you guys this when we go into the controller section of the software. But what we're doing is we're taking from whatever DMI slot. So in the case of our OptiCore device is going to be in DMI slot number 1. And we're taking whatever is in DMI slot number 2 and then routing it directly to that. So in the case of this church that we just recently did in the last 6 weeks, is they had both Dante and MADI devices that were coming from Video World, Dante devices that were coming from multiple places on their campus, and then A-star devices that were in overflow rooms or multi-purpose rooms. And so with this, you're going to take those lines, in this case, it's showing you like 24 inputs as this, you know, direct grid, and putting up those 64 inputs onto the network. So They can be coming from multiple DMI devices, local IO devices, a combination of what you have going on there. Once you do that, go ahead, Ryan. Oh, sorry.
Before we advance, on the 4U4, you actually need to go into the engine tab. We're going to walk you through the software in a minute, but through the engine tab, audio, IO settings, and configure that DMI port properly. So this is where you can actually tell it if it needs to have rack control, right? And then you'll see obviously stats on the unit itself. But I think this is a MADI port, right? Yeah. So if we were going to a octa-core port, octa-core DMI card, we would actually have the option for I think, do I have one in the next slot? Hang on a second. I think I do. There we go. So there is configured on DMI port with the octa-core card. So we'll actually have an octa-core ID. You're going to see that the connection's okay, and then the channel connection count. And those do need to be configured as 56 channel when you're doing rack control. Correct, Kyle?
Correct. Yeah, and you can, if you're not doing, you can do 64 channel also if you need just more channels, but then you will not get the rack control portion of it. In the case of what we were doing in the church, we didn't need any rack control of inputs from their main rooms into that. So what we did is we did 64 channels just to give them 8 more channels to pass audio back and forth between the venues.
Cool. And then you could always add another octa-core card, assuming you had room on your octa-core network for more channels to get additional IO back and forth. And maybe one of those could be configured for rack control and another could be configured just for, sheer amount of audio channels.
Yep. Yeah, so now when we go into our actual DiGiCo SD series console, you're going to go into your audio IO section. If any of you have used DiGiCo before, you go into audio IO. This is where all your inputs and outputs exist in SD series. And with this, you're going to create a port. So in this case, in the diagram, we're just putting on rack 1, and we're selecting the device type as a 4 area 4. You can see those are the devices that can come in. Again, on SD series, you're going to have, you can have up to 14 rack type devices. So whether those be SD racks, D racks, anything that can exist. So 14 of those racks that exist on the octa-core network. You can also do this if it was MADI, you would select it as a MADI device.
Once this connection is showing us MADI.
Is a MADI, yeah.
Yep, and if we were set up with octa-core, we just go down to the add port and add the appropriate octa-core ID that we set up in the slide before.
Correct. And if you hit conform all ports near the bottom left there, it would actually pull in that information if you've already set up your octa-core card inside the 4 area 4. Then from there, at the bottom, it says conform rack. When you hit the conform rack underneath the grayed out picture, there you go. That conform rack, that's going to pull in, say, for instance, in this situation, if our first card slot was 8 microphone inputs from the 4 area 4, the next slot might be Dante, the next slot over might be 8 channels of MADI. You're going to configure that in the tie lines, and when you conform the rack, it's going to let you know what the port is, and if it's a rack device that has preamp control or 48-volt control, then you're going to actually get that gain control and 48-volt control via the patching pages inside of the SD console. So again,
so what you're saying on workflow is it's good to set up the 4U4 first.
Correct.
Set up all your tie lines, set up your octa-core DMI card, that octa-core ID, everything that needs to happen on that system. And then on the SD software, we'd be able to really make it easy by just going in and hitting the conform all ports and the conform rack if needed.
Yep.
Nice.
Yep. And again, if you name the inputs inside of 4 area 4, it will actually pull those names over. So it'll pull the existing name from 4 area 4. Tim, is there anything else that's coming with this? I know we've recently, the octa-core portion just as of like last October started working. Anything else that's coming for this in the future?
Not as far as I'm aware. I mean, I think that lots of things have been looked at, but nothing that's set in stone at the moment. Nothing that I can talk about anyway at the moment.
Yeah. Anything you have to add to this, just because the integration part is so new? Is there anything else you have to add to what we're talking about here?
No, I think you've covered it pretty well. I mean, it was obviously a pretty comprehensive install you did here, and I think it's one of the first ones I've seen where it's had this level of integration. So
Yeah,
it's
and
pretty impressive.
when we started talking about it, we actually did a master series training at their venue back in December, and they were talking about what exactly they were doing, and it didn't really make a lot of sense until I actually got there and saw exactly what they were trying to do. But it's the flexibility and being able to take anything from any of the 3 consoles they have, putting those on the network for any of the other rooms to grab, or vice versa, anything that they're doing in the other rooms to be picked up into the main room when broadcast. They had broadcast console, monitor console, and front of house console. Really flexible, being able to pass things back and forth inside this one campus. So it's pretty exciting.
Awesome. Cool. Well, thanks, Kyle.
Yep.
I am going to jump in and show everybody the software. So as we're going through this, I'll take you guys through what we're doing. If you have the software, you're obviously welcome to follow along. I don't know if you have multiple screens or not where you can see what I'm doing, but you're welcome to follow along in that. The software is available on the DiGiCo website. So if you go to digico.biz, I believe there's a Discover DiGiCo tab, a Support tab, a Software, and then from there you can find all the necessary downloads for either PC or Mac for your appropriate computer for the 4U4 system. And that'll include the latest software as well. Once that software is installed on your computer and you're actually connected to a unit, you'll actually have the option to upgrade the unit. So here, I'm actually already connected to this. So you guys are seeing my software, correct? And the main connection here is where the main tab is where we're going to control everything from. But this system tab with a green light. Green light obviously means we are connected to the 4U4 platform. And just to show you kind of what this process is like, I'm going to disconnect from this unit. Once I'm disconnected, you'll actually see that I can select the 4U4 that I need to control here. And I can then go in and say, okay, here is the firmware version, the current version, and the new version. So here we can see that engine firmware is running the latest, which is 1.32. This was a limited release that we did that I'm running right now. And then the main engine firmware is running on software version 1.2, which was the last public release that we did. It's giving me my IP address. By the way, this IP address that it's giving you is the standard out of the box. You just ordered a 4U4, came fresh from the factory, is going to come with that IP address as you drop it onto your network. Of course, that's in the documentation, which nobody reads, but that's okay, it's there. Now, before we connect to the unit, if you need to program stuff ahead of time, there is an online tab and an offline tab. If I go to the offline tab, I can actually configure which cards are in which ports. So here you're going to see there's a Matty B card, here there's a Dante 6496 card, and then here there's a generic ADC, AES, etc. And then I can choose what's in all of my SD slots as well. So that will allow you to do patching from inputs and outputs ahead of time before you actually connect to the system. All right, since we have a unit with us, let's go online. Let's hit connect. So it's actually going to pull the settings from the unit. You obviously have the option to push settings, though I'm sure most of you know 99 times out of 100 we are going to want to pull the unit, pull the settings from the unit. So this is doing a full session file transfer across the network. So it can take a second to do it when you're connecting right out of the gate. I'm also pushing a bunch of audio over a Dante network at the same time, so keep that in mind. All right, so here is our software that we're actually going to control with. And let me just give you a brief tour around what you're interfacing with and what you're going to see. First off, if you do have a touchscreen device, Kyle was mentioning on that install earlier that they had like a Dell multi-touch display. I forget if it was an all-in-one or display, but that's going to allow you to be able to do a lot of this directly from a touchscreen. So in certain applications, maybe some of those chapels or fellowship halls or meeting rooms or whatever your setup is, if you want the full control, but you still don't just want to keyboard and mouse it around, you can grab a touchscreen and interface with it from here. So as mentioned before, we're on the main tab in the top left corner, and then we have our 4 areas across the top. So here we can switch to the second area, which I don't have anything set up in right now. We can go to area 3 or area 4, same type of thing, that we don't have anything set up in those areas. So area 1 for me is currently running all of my audio channels and pushing audio in and out. Here along the top section under your areas, you're going to have a bank of 12 faders, another bank of 12, and another bank of 12. This is going to be very similar to how an SD10 is laid out. And then you're also going to see your bank select buttons down here. Now I can select them from this window here. Also, once I have a channel selected, it's going to populate my main area. I can control A, B, C, D, E, and F from here as well. And then if you look next to bank number C, here in a minute, we'll see if the audio does it for us. You're going to see that this is actually a clip indicator next to C. So we're going to see it both at the top area as well as this larger view down here. And as these inputs clip, it's going to show us and we'll be able to just draw our attention to where things are clipping. So these are individually assignable. Every channel bus's inputs or outputs. These can be flexibly laid out however you need them to be. So I currently have this configured for inputs 1 through 12, 13 through 24, and then 25 through 30, all set up right here across my first 3 layers, so I don't have to bank around. A little bit later, I'm going to show you how to set up things like aux-ins and your master area for you to be able to have control of the outputs as well. Now, if you follow me down the right-hand side, you're going to see that there's macros. So we can configure any one of these buttons to trigger a certain GPI command into the system, firing specific snapshots, things like that into the system. This is actually 26 of these are available, so you can scroll down just by hitting the buttons or by scrolling with your mouse if you have a mouse scroll wheel. You're going to have meters for these for the solo bus. So if I solo something, let's go grab this channel. So now you're going to see that my solo bus is lighting up there as well. All right, and then you're going to have talkback controls, copy channel setting controls, and snapshot controls all right here. So we can create a new snapshot, store those, update, and then fire and fire next, fire previous, or fire a specific snapshot. Right? It'll tell you which the name of them are as well, both the one that you've selected and then the one that's coming up next. Currently, these were set up as room 1 is the way they were labeled. So to configure rooms where those, how those snapshots were configured. All right, so once we have a channel selected, so I select the channel up here, you can see my gold box selecting my channel. You'll see that that bank of 12 has spilled down here with more detail. So I can, right from the screen, grab faders, make changes. You saw me before solo a channel. I can select that channel, same type of thing as clicking on it, mute the channel, and then turn it on. So if you're familiar with DiGiCo, you've been with us for a while, this is new to you. We have to turn a channel on. Turning it off would be the equivalent of muting it. I think in an installed application, this makes a lot more sense where you're actually typically using less numbers of channels versus the opposite, like in an SD7 or an SD12, where you're probably going to have the majority of channels open and controlled by control groups. All right, in addition to that, you'll be able to tell if it's muted via a control group. You'll also have a mix select button, which we'll get to in a minute. All right, so hopefully that helps you with your basic navigation. You'll notice there is a smaller display here with a little window, little arrow. So when I push this, it actually pops out the view for us to set up our system. This is a lot like going to the master screen on an SD series console. So here we can toggle back and forth between these two, just showing us both the expanded channel view and our engine in more detail. So, interestingly enough, the first place we want to start, just like we would start with any SD series console, is with the session structure. So you're going to find that under the Engine tab, and then you're going to find it under Configuration and Structure. Currently, you're going to see we have 0 buses remaining and 0 and 8 effects remaining. We can actually adjust these numbers by clicking and dragging down. If I do that, I'm getting rid of mono and stereos on both auxes and effects, groups, effects, auxes, and matrix. So you'll see if I get rid of all of these, then we're actually going to be looking at 0 on all these categories and 48 remaining and 16 effects remaining. Okay. All right. So what we're going to do for today is one, we're just going to cancel out of that, bring that back to our defaults, which means that there are 4 mono and stereo groups, 4 effects, monos and stereos, 4 mono and stereo auxes, and 4 mono and stereo matrix. Okay. Obviously, if we made changes to any of these, we'd need to apply those changes here. We can do that. Any questions there? Is everybody pretty good? All right, hopefully that's pretty straightforward. Now, actually, we want to get into what we call area management next. So you'll see I was in the structure tab before. I'm now in the area tab, and you'll see that there's area 1, 2, 3, 4, and then of course seeing all the areas. Now, area 1 is already set up for me. So you're going to see I have channels 1 through 32 in here. They have a little 1 icon in the bottom to let you know they're in there. Now, what I want to do is I actually want to take you through area 2. So I actually want to grab like channels 37 through 42, and I want to put those in. So I just grab these channels and I want to put those in, I want to put those in the second area. So area 2 is highlighted. Now you're going to see a little 2 icon under all those channels. And if we go up to area 2, we would actually need to now put them on the controllers, but the actual inputs are assigned to area 2. All right, the other thing you need to look out for here is you can prevent assignments to multiple areas. I currently have that on and that's green. I could turn that off, and if I turn it on again, it's going to say this action will remove strips assigned to incorrect areas from all connected instances of controllers. So that means that is physically going to pull away channels from other areas they shouldn't be in or from not their primary ones, meaning that it won't allow input channel number 1. Remember, that's 1 channel worth of DSP to be assigned to area 1, 2, 3, and 4. There could be situations where you may want this, so just know where that control is and if you want to turn it off. You can reset busing on area changes, so that's actually going to toggle and basically clear busing, so you would hear that change, obviously. And then we could set area safes on area change as well. So basically the master area gets saved from the snapshot section when you assign these channels in. All right, so here you're going to go back to area 1 and you're going to see that channels number 33 through 42 are not available to area 1 because we've assigned those to area 2, and we also have prevent assignment for multiple areas engaged. Right? Now, we can also go through and set up where we want our effects, our buses, etc. Now, what I would like to do is go ahead and set up a couple of auxes and apply those to area 1. I would like a couple of stereo auxes. I want a couple of, let's just do, we'll cut to it and do a couple of stereos. And then obviously you're going to want area 1 out to be applied there as well. So now we have 32 inputs. We have a couple of mono and stereo auxes. We have a couple of mono and stereo groups. Actually, I didn't do groups, but tell you what, we're here. Let's do it. We'll apply those into this area as well. So we have a little bit of everything so we can play with that and see how those look in a minute. You can also take your control groups. We have 24 of those. Maybe I just want 4 of those and be able to apply those into area 1 as well. So we're doing our area assignment here, being able to take specific channels, buses, control groups, etc., and assign those directly in. Now, the next area after you do your area management is we actually want to control the layout. So if you go to control, we actually want to assign these channel strips. So remember, we're in channel 2 right now, and we still have 12 channels here, 12 channels here, 12 channels here by 6 banks, A, B, C, D, E, F. So I want to go in and I want to assign the channels that we have available to us. I'm going to grab block select, and I'm going to grab the first 4 channels, and I'm going to move those down to this first bank. When I do that, you'll see the 4 channels show up right here on the left-hand side. I could grab the next 2 channels, skip a little spaces, put them over here, set my layout how I need to. Going back to the main area, layer 1, or area 1, I'm sorry. Let's see, I want to go put some auxes that I set up earlier. So I'm going to go to my bus area. I'm going to set aux 1. I'm going to put it here. So I'm going to put my 2 mono auxes. I'm going to put 1 of my stereo auxes here, and then I'm going to grab that area out and throw it over here on the far right-hand side. So you're actually going to see that we're in bank 3. That means we're controlling this third bank. Bank 2 would obviously be the middle bank. And then within that, we have our different layers, so we can go through and put a lot of channels per area if we need it. And that's the basics of dragging it around as you need it. Now, let's take a step back and look at controllers. So these are physical or tactile controllers for the unit, and there's 2 ways to set these up. One of them can be done directly from the engine. So we're on the engine tab, we're in controllers, and we're going to go to device manager and actually set up whether we have AC1s, AC6s, or AC8s. You're going to see my AC8 is actually connected here, and it's locked. We can name the unit if we wanted to in here, add other devices, remove this device as well. We can set up AC1s, AC6s, AC8s, and A88, the GPIO module, directly to the engine. We can also connect them to the controls software. So this is something important to understand. We can set up all the controllers directly to the engine as well as directly to my laptop, which is the one running the controls software right now, which is pretty awesome because that allows you expanded controllers. Maybe you want to specifically bring in your laptop, specifically bring in an AC8 so you can have control over that section when you need it. However, keep in mind that if I remove my laptop from that setup, that AC8 that I connected to my laptop would no longer be talking to the engine. To do that, I need to set it up under engine and have that AC8 connected there all the time. That way, if I disconnect my software, it's not going anywhere. So let's look at our quick setup for this AC8. You're going to see here that my first bank, first off, I have the number of layers set to 4. So that means that 4 of these buttons, let me switch over. If you can see my camera, which I think has gone to sleep on me. Can you guys see it? There we are. So you can see my AC8 here. That means these first 4 bank buttons, those are going to give us control. The last 2 are not going to do anything. We can actually take those, and I would call that hijack those for other things, like GPI triggers and things like that. So the first 4 banks are going to be set up. So layer 1 on my software is actually going to be showing me the, layer 1 here, and then I can pick and choose. You're going to see I have channels 1 through 6, and then the master area built right in. So I might want to go to layer 2, go to the buses, and directly put on all of my auxes. So if I want to put all of my auxes here, I could put all of my auxes on layer 2. Now if I switch the camera over so you guys can see, and I go to all of my auxes, we're actually going to be looking at our aux masters right here on my bank 2. And then if you follow along in the software, you'll actually see that I'm controlling aux 1, 2, and aux number 5, which is the stereo guy here that I put on my software control. So I can control it from the software. I can also control it directly from the hardware, one and the same. I can solo it from here, listen to it, also directly mute it from here as well. Okay. And then hopefully that lets you guys understand how it is. If there are advanced controls, you're going to see them in here. Primarily, that's going to be when we're like controlling with like an AC1 and we need to be able to control like the shift button. So what is the rotary shift function going to do? We can move it from an unused function to a pan function. An area aux send pan, FX send, matrix pan, source select is the primary number that I have. So source selector 8 in this case. And then we actually have a simulator. So we can actually go through and see what the shift does in these cases. All right. All right, so those are your controllers. Kyle, do you remember the limits on the controllers right now? I was thinking it was 16 controllers, but can you confirm that for me?
It should be 32 controllers of the AC1.
Right. That last update they did, didn't they? So it's 32 AC1s, and then we're going to have 16 AC6s, 16 AC8s, and then 8 GPIO A88s. Cool. All right. Any other questions, Kyle? Is there anything you can think about that I need to cover on that?
I think that's good. We do, for everybody watching, we are monitoring your Q&A, and we will get to those after we get through the presentation. We'll go through and touch on some of those things you guys have been asking. So just hold tight with those questions. Make sure they keep coming in with those. So, but we will get to those when we get done with this portion of the presentation.
Fantastic. Thanks, Kyle. Sounded so official. All right, so that was controllers. Let's jump on to routing really quick. Here is a routing tab. This is a very simple point-to-point cross-routing matrix. So you're going to look over on the left-hand side. So once again, we're doing outputs right now, so apologies for jumping you around. Outputs on the top, inputs or tie lines. So these are our three master sections. Among outputs, we have bus outs, input direct outputs, so that's direct outs from the channel, rack effect sends, and solo outputs. And if we wanted to tie our solo bus to our headphones, we would do that. And you would see here that solo bus number 1 is already assigned to our headphones. But if we needed to make it solo 2, so from the area 2 solo bus to the headphones, we could change that here as well. If we wanted to also send that out to a Dante card, we could do that as well. So here, this would be our solo bus coming back out of Dante, right? Also bus outs as well. If I wanted to take those to an A3232 unit, I actually have an A68 stage connected just out of frame over here, but I can tie those outputs directly to that unit as well. If it's black up here or dark gray, that means you don't have access to those. Those are not patchable, and it'll give you this little icon with hash marks through it, so you'll know that it doesn't work. All right, then there is an input section, so patching inputs as well. So we can get in and individually patch. You're going to see here that I'm taking my input channels from DMI2. So this is my Dante patch. If I start unpatching some of these channels, you're going to notice that they move away. And then once I get them in there, you'll see that input to channel number 1 has gone away, which I think is a kick drum anyway. So it's going to look like it's coming and going. Cool. Audio playback would be the internal wave playback. So if you've used that USB drive that Kyle was telling us about earlier, then that one will actually, that'll give you the wave files access to where you want those to show up in which input channels. Tie lines, this is just point-to-point as well. So I want to be able to take the local inputs to something like, I don't have an opticore card installed in here, but let's say it was on number 3. So Opto 3, so we could get in there and start patching things. And then when I do have the opticore card, I could be taking my local inputs directly to that, or I could be going through an A-star port and doing the same type of thing. And hopefully that makes sense to everybody. And then processing. So there's another tab down here at the bottom for processing, and this isn't going to do anything until you select a channel. So once I've selected a channel, this will be hopefully very straightforward and very common to anybody who's really used a digital console in the last 10 years. So this is giving you basically the processing view for 12 channels from this first bank up here. So you're going to see input number 1 through input number 12. You're going to see meters at the top. You're going to see things like your gates, your dynamics that you have involved. You're going to see things like your high pass filter. You're going to see your EQ, your dynamics panning as well directly into that area, and then your output meter for that channel. Now we can touch a section and go directly into this. So if I want to start applying EQ to any of these, I can just start grabbing bands, moving things, making adjustments. Of course, this is a normal EQ, right, Kyle? This is what normal people do. So anyway, if I go to the bank, I can jump directly into a section that I want to control. Like you saw me with EQs, I can also jump right to the filters. So if I want to grab my input or high pass filter, I can grab that from there, or my low pass filter. And of course, adjust the slope for that as well. Get into my gate. We have an insert here. We have EQ comp. So we can key off of ourself choose whether we have a filter engaged so we can filter what's coming in to trigger that. Obviously control over the knee of the ratio. We can manipulate these via on-screen as well and really get in there and get some aggressive compression going on there. I bet that sounds amazing once that's engaged. Cool. Insert B would be followed up and then delay as well. And then your overview is just kind of a view of basically every section, allowing you to quickly control one of those and jump right into those sections as needed. Anything I'm leaving out there, Kyle?
Yeah, let's get into the AMM control.
Oh, yeah. So I did ask you to remind me that if I forgot that, didn't I? So let's go back to the engine, and then we're going to go to audio, and then you're going to see a couple of more tabs, and you're going to see AMM. So AMM stands for auto microphone mixing. Sorry, apparently I've forgotten how to talk here in the last few minutes. Automatic microphone mixing. This is a gain shared automatic microphone mixer. So it's going to look at the different levels of the channels that you have going into it. It's going to, if you had one channel, it would open up to 0 dB. If you had two channels open, they would go to -6 each. Essentially what you would do with your fingers on the faders if you could do it fast enough. So this is looking at this. Currently, with the AMM, I'm in setup mode, so I can take a look at a few different things. Input assigning is the first one to look at. One, we can actually drag channels directly into here. You'll notice that there are 2 groups by default, but we can go to 4 groups. So these guys are going to give us 16 channels per group, or we could drop down to 2, and that would give us 32 channels per group. And then we could obviously drop down to 1, giving us a total of 64 channels that we could automatically mix together. That would be a horrible event to go through, but in the right application, if you need that much automatic microphone mixing, it's here. So let's leave it set to 4 groups for right now. I'm going to grab a couple of channels like channels 1 through 8. Although these are musical sources, you'll get the idea of what's going on. So we've just assigned channels 1 through 8 into there, which are drums, which is something you should definitely not automatically mix. But anyway, you'll see them going in here. You'll also be able to tell which channels are on or off within those, so we can individually control those and their weighting. So obviously I would weight my kick drum really high in this setup, and we'd be able to look at how we're actually implementing these channels. This powerful channel will get turned down, and now you'll actually see stuff start to move around for what that is. Does that help everybody?
Hey, Ryan.
Yes.
Hey, one thing we should mention is that the AMM card is actually, it's built in. You do not need a DMI card with the 404 for this option.
That is correct. Yeah, so if we went back to that DMI list that we were looking at earlier, the AMM was not mentioned. If you're running an S-Series console or an SD-Series console, and it has a DMI card slot, you can put the AMM card in it to do this same function on the console. Here in the 404, it is built in and available. You do not have to use one of those DMI slots to be able to use this. It is built in out of the box. I think most of you are going to be familiar with AMM and what it's used for. This obviously allows for a lot of applications. I would think a lot in theaters, churches with like fellowship halls and multi-purpose rooms, corporate venues, hospitality. A lot of times you just need a couple of wireless mics in somebody's laptop input from that, or a video input or something like that. And you don't need somebody there to operate this, nor do you need a controller. So being able to automatically, recall a preset, have your wireless microphones automatically go to an automatic microphone mixer, and just kind of set it and forget it at that point is pretty awesome. All right, cool. I'm going to try to wrap up very quickly so we can get on to our Q&As. Real quick, we're just going to briefly look at snapshots. No need to go super in depth with this. The one thing to know about snapshots is you start in your snapshot manager, and you're going to notice here that we have just a couple of different snapshots from the beginning. We can recall these. We can undo what we're doing, obviously edit the names, storing, deleting, recall, all the basic functions that you would hope for, including copying a snapshot and pasting that in another location, so like if we wanted to duplicate it. But also you're going to notice that we actually have a lot of these slots already pre-populated. And when we get to 201, you're going to notice that they're grayed out. So what we've done is we've set up 200 snapshots for area 1 that are specific to that area. And then we have snapshot 201 to snapshot for, if I can see if I can count correctly, 400 is going to be available for area 2. 401 to 600 is going to be for area 3, and 601 to 800 is going to be for area 4. That means we have 200 snapshots that are available per area that are specific to those areas. All right, we can obviously update specific snapshots. We can get into the editor, we can rearrange things, imports from other sessions, and then we can also get into the safe section as well as area safe. So this would be all areas. So that area out, for example, we can control those separately. Okay. Cool. All right, and then user setup permissions. So back, if we go back under engine, and then we go back under configuration and user profiles. So, so here we're going to go over the fact that we have an admin set up. Admin's going to be there and not going to let you delete it as you would expect. And then you're going to see I've set myself up actually as an admin. So we have Ryan in here. I can set my own password. I can control which snapshots are mine. So if I want to fire a specific snapshot when I'm logged in, also the area that I have control over. So you're going to see those specific areas there as well. I can also set the permissions. So specific configurations that I can control, all these things that are checked I have access to, and there are things that I can do in here. So very quickly I can enable all, so that would give me control over everything in my area, which would be great for an admin. And then from there we can lock down users to specific areas.